That's cool.
Okay, rigid motion in a plane. Rigid means it doesn't turn or anything, you know, or tilt. It stays its same shape. You did this in 7th and 8th grade. The transformations. There is translations, which are the easiest to do. Translation is just a slide. You just move it, but it doesn't turn or flip or anything. There is reflections, like when you look in a mirror. A reflection, you learn in elementary, they called it a flip. Reflections are backwards. You know, like when you see yourself in a mirror, you're seeing yourself backwards. Yeah. And then there are rotations. Rotation is just you turn it. Okay? So, image is like when you look in a mirror, you see your image, right? Everyone knows what that is, I hope. Yeah. Okay? So this is after the transformation. Now, they use the word pre-image. Pre means before. So pre-image is before the image, which just means it's the original. Okay? So when you look in a mirror, you're the pre-image, the mirror is the image. Okay? So pre-image and original are the same thing. Isometry. You guys did isometric drawings?
No.
In 8th grade or 7th grade?
No.
It's where you had the block of something and you had to draw the three, the front view, top view, side view.
Oh yeah, I did that. I did that.
Okay.
Shut up.
Wait,
I did that.
Yeah, everyone does that. You just don't remember.
Yeah, everyone.
They're called isometric drawings because you measured them with a ruler and then you drew them the same size. The top view is the same size as looking down the front view. Isometry just means it doesn't change size or shape. So, these three are all isometries. If you slide it, translate it, it doesn't change size. Reflect it, it doesn't change size. Rotate it, it doesn't change size. Okay? So they're going to have this in every section. They're going to just remind you that it's an isometry. Okay, today we're not going to describe, we're just going to name the transformation. So a translation means it looks exactly the same. It's just in a different spot. A rotation, it's been turned. If you turned your book or your iPad, then it would eventually look exactly the same. A reflection is it's backwards. So if you notice here, they've got ABC. Here they've got, shh, quiet. Can you guys see the little tick marks there?
Yes.
Oh, yeah, I don't have my glasses.
With my new glasses, I can.
We did this last year.
We did?
This is the original triangle ABC. This is the image, A prime, B prime, C prime. That little tick mark there means prime.
Wait, didn't we do this?
So, yeah, we did this last year. So, what this means is when you see these tick marks, that means that is after it's been moved. This is the image. So that's how you can tell which is the original. If they moved it again, the second time, you'd have two ticks. Like, yeah, if you moved A down here, they'd call it A double prime. Okay? So, again, we're not going to describe it because we haven't done them yet. We're just going to name. Is that a translation, a reflection, or rotation? Translation. It's just been slid up. Okay? Now, just to show you, eventually you are going to describe it. To describe it, to get from, you can choose any 2 points. To get from A to A prime, I go right, 1, 2, 3, 4, 5, 6, and up 2. So that's explaining it. You can write this way. Instead of using rounded for coordinates, it'd be 6, 2 like that. These brackets represent a vector, which we'll be doing. A vector is like airplanes flying a vector from one spot to another. They fly in a straight line. So this is the directions. The first one's the X, the second's the Y. If you ever saw a vector like this, that means you go left 3, up 1. Okay? The long way that they write this, so I'll just use this one, is they put X, Y, and then they put an arrow. So that just means move every X and every Y. X minus 3, that just means left 3, and Y plus 1. These are the two ways to write translations. The easy way, the harder way. But they mean the same thing. So here they ask, is triangle ABC congruent to its image? Yeah. It's an isometry.
Kylie.
Okay, so here is the original ABC. Here is the image. It is a reflection. Okay, so again today we don't have to describe it, but I'm going to show you because eventually you are going to describe it. If we describe what it is, it's a reflection in the x-axis. They don't say over, they say in. It's like when you look in a mirror. Because if I drew this line right there, that's the line of symmetry. This would fold onto that if you folded it right there. Can everyone see that? So that's why they say it's flipped over the x-axis, so they say in the x-axis. And this one, here's the original. It's not translated.
Rotation. Couldn't it be rotated over the
It is a rotation, yeah. You can see it's not a reflection because if it was a reflection, it'd be diagonal, right?
Yeah.
Since A is here, A would have to come up to here somewhere if it was folded over. So the only thing that can work is a rotation. Okay, these are simple. Yes or no? Does this appear to be an isometry? No. Isometry means same size and shape. Does this one?
Yes.
Yes. It's been reflected. Stays the same. This one?
Yes.
It's supposed to be. It's just the paper got a little curved there.
Because it looks smaller.
It looks smaller because it's curved, but it is supposed to be the same.
Yeah, 2.
All right. So they're saying this is a reflection. So what that means is they're both the same size. They want us to find the length of NP. So how long would NP be? It'd be 9 because it's the same as that side. And the measure of angle M
48.
would be the same as that, 48. Okay? So that's all it is. It's pretty simple. Is this an isometry?
Yes.
Yes. Find xz here, since it is a rotation. Xz is the same as AC, so that's 17. And the measure of angle y is the same as B, which we got to figure out. It would be 90, yeah, because 36 and 54 is 90, which means this would have to be a 90. So x, or angle y, is also 90.